Hi, welcome to Physics 5.2a on work and power. First, let's define some things. One, when do you do work? Well, work in physics has a very specific meaning. In physics, work represents a measurable change in a system caused by a force. If you push against a wall and the wall does not move, you've actually not done any work, because there was no actual measurable change of the system. However, pushing does make the wall move. Even a little, you've done work. If you push a box with a force of 1 Newton for a distance of 1 meter, you have done exactly 1 joule of work. On your formula sheet, you're going to want to put a box for work horizontally. Horizontally, work in the x direction is force times distance in the x direction. Work is measured in joules, force is measured in newtons, and distance is measured in meters. Remember that force is mass times acceleration, and we have several equations for acceleration. Remember that we don't always just have to find work. Sometimes we have to find force, which is work divided by distance, and sometimes we have to find distance, which is work divided by force. If we're doing work vertically against gravity, we have a similar equation, but remember now we've got gravity involved, which is 9.8. So work in the vertical direction is mass times AY times dy. Work again is measured in joules, mass is in kilograms, acceleration is gravity in meters per second, which on planet Earth is 9.8, and d is the distance, the vertical distance the object is raised, or the height. Remember that we don't always just have to find work. Sometimes we'll need to find mass or vertical distance. Mass is work divided by acceleration divided by distance, and distance vertically is work divided by mass divided by acceleration. Be sure you add this to your formula sheet as well. So why does the path not matter? Notice that if I'm going up the stairs, it doesn't matter what direction I go. The actual work done is work against gravity. Mass times gravity times height. To calculate work done against gravity, a crane lifts a steel beam with a mass of 1,500 kilograms. Calculate how much work is done if the beam is lifted 50 meters into the air. And then, how much time does it take to lift the beam if the motor of the crane can do 10,000 joules of work per second? For power, power is how powerful are you? It makes a difference how fast you can do work. If you pull a box 10 meters, does it take you 10 seconds, 30 seconds, or 60 seconds to pull the same 100 Newton box? Well, work and power are different. 10 seconds would be 1,000 joules or 100 watts, whereas if you do it in 60 seconds, you've still done 1,000 joules, but now you've only exerted 16.7 watts. A unit of power is called a watt. Another one you're probably more familiar with is horsepower. 1 horsepower, which is the average output of a horse, is equal to approximately 746 watts. The power it takes to raise your arm 3 centimeters in 1 second can also be measured in horsepower. 1 watt is equal to 1 joule per second, and 1 horsepower is 746 watts. You'll probably want that conversion on a formula sheet as well. So power is equal to the amount of work done divided by the time it takes to do the work. P is W divided by T. P is power measured in watts, W is work measured in joules, and T is time measured in seconds. But we don't always just have to find power. Sometimes we have to find work, and sometimes we have to find time. So work is power times time, and time is work divided by power. To calculate power, a 70-kilogram person goes upstairs 5 meters high in 30 seconds. How much power does that person need? And compare the power used with a 100-watt light bulb. So another way to express power is as a multiple of force and its velocity. Power is force times velocity. Power is measured in watts, velocity in meters per second, and force in newtons. But we don't always just have to find power. Force is power divided by velocity, and velocity is power divided by force. Thanks for watching.